Download this code from codegive.com, link in the description below. Hibernate's default connection pool, pitfalls, troubleshooting, and alternatives, with a Stack Overflow angle. Hibernate, by default, uses a very basic, built-in connection pooling mechanism. While convenient for simple applications and quick prototyping, it's often inadequate for production environments or applications requiring more robust connection management. This tutorial will dive deep into Hibernate's default connection pool, explaining why it might not work as expected, how to identify the problems, and how to use more robust alternatives. We'll address common issues often encountered on Stack Overflow. Understanding Hibernate's default connection pool. Hibernate's built-in connection pool is essentially a rudimentary implementation. It maintains a small number of connections, typically just one, handles basic connection reuse, and offers limited configuration options. It is not a dedicated, high-performance connection pool like hikaricp, C3P0, or dbcp. Why the default connection pool might not work, and what that really means. The statement Hibernate's default connection pool isn't working usually translates to one or more of these problems. 1. Performance bottlenecks *, the most common issue. The default pool's single connection, or very few connections, becomes a bottleneck, leading to slow response times, application stalls, and poor concurrency. Imagine a scenario where multiple users are simultaneously requesting data. If each request needs a database connection, they'll be queued up, waiting for the single connection to become available. 2. Connection exhaustion * in more demanding scenarios, the default pool can't keep up with the connection demand, leading to SQL exceptions related to obtaining a connection. This is especially true in web applications under load. 3. Configuration issues * misconfigured connection properties, example incorrect JDBC URL, username, or password, will prevent the pool from initializing or acquiring connections. 4. Deadlocks * in complex transactional scenarios, the limited connection pool and inadequate resource management can contribute to deadlocks. 5. Connection leaks * if connections are not properly closed and released back to the pool after use, the pool's available connections can dwindle, leading to exhaustion over time. While the default pool is quite simple, the issues are frequently related to improper connection management in your application code that interacts with the database through Hibernate. 6. Unexpected behavior * because it is a rudimentary solution, its behavior in complex use cases, like nested transactions or long-running transactions, might be unpredictable and lead to subtle errors. How to identify connection pool problems. 1. Error messages * the most obvious indicator is exceptions like java.sql.sql exception, no suitable driver found for JDBC URL, java.sql.sql exception, too many connections, or errors related to connection timeouts. Examine the stack traces carefully. These errors might not explicitly mention connection pool, but they point to the underlying inability to acquire a database connection. 2. Performance monitoring * use profiling tools, example Visual VM, YourKit, JProfiler, or application performance monitoring, APM, solutions, example New Relic, Dynatrace, to monitor database connection usage, response times, and overall database performance. High database latency and slow query execution times often point to connection pool bottlenecks. 3. Database server logs * review the database server logs for connection errors, rejected connection attempts, and performance issues. Most databases provide extensive logging that can help diagnose connection-related problems. Specifically, look for errors related to exceeding the maximum number of allowed connections. For code review *, carefully review your code to ensure that you are properly closing connections and releasing resources after you're done with them. Use try with resources for JDBC connections and ensure that Hibernate sessions are properly closed, example within a finally block. 5. Increase logging, temporarily enable detailed logging in Hibernate and your database driver. This can provide insights into connection acquisition and release patterns. For example, in Hibernate's configuration, example hibernate.cfg.xml or application.properties, you could add 6. Simulated load testing * use tools like JMeter or Gatling to simulate concurrent users accessing your application. This can help expose connection pool bottlenecks and identify performance issues under load. Start with a low number of concurrent users and gradually increase it until you observe performance degradation or connection errors. Example scenario and code snippet, illustrating connection exhaustion. Imagine a web application that displays a list of products from a database. If the application uses Hibernate with the default connection pool and experiences high traffic, the single connection in the pool can quickly become overwhelmed. Hibernate.cfg.xml, example, with default pool configuration, which is implied if not specified. In a highly concurrent environment, multiple requests to get all products will likely be serialized, waiting for the single connection to become available. Under sustained load, this can lead to connection timeouts or general performance degradation. Even a very small number of simultaneous users can cause problems. In a real-world application, the problem becomes more significant, because database interactions are often more complex than simple data retrieval. Alternatives to Hibernate's default connection pool. The solution is to use a dedicated connection pool. Here are a few popular choices. 1. hikaricp * highly recommended for its speed, performance, and ease of configuration. It's often the preferred choice for modern Java applications. 2. C3P0, Combo Pooled Data Source, a mature and widely used connection pool, but generally considered slower than hikaricp. 3. dbcp, Apache Commons dbcp, another popular connection pool. Version 2 is recommended. Configuring hikaricp, recommended. 1. Add the dependency * include the hikaricp dependency in your project's pom.xml, if using Maven, or build.gradle, if using Gradle. 2. Configure hikaricp in hibernate.cfg.xml, or application.properties. Instead of directly setting connection.driver_class, connection.url, connection.username, and connection.password, you configure Hibernate to use hikaricp as the data source. Hibernate.cfg.xml *. Application.properties, Spring Boot. If you're using Spring Boot, you can configure hikaricp in application.properties or application.yml. Important note: Spring Boot will automatically use hikaricp if it's on the class path and spring.datasource.url and related properties are defined. You don't usually need to explicitly set hibernate.connection.provider_class in a Spring Boot application. 3. Key hikaricp configuration properties *. Minimum idle, the minimum number of idle connections that hikaricp will maintain in the pool. Setting this too low can cause frequent connection creation and destroy cycles. Maximum pool size, the maximum number of active connections that hikaricp will allow. Adjust this based on your application's concurrency requirements and database server's connection limits. Important: set this value lower than the max_connections allowed by your database server. Idle timeout, the amount of time, in milliseconds, that a connection can remain idle in the pool before being closed. Max lifetime, the maximum lifetime, in milliseconds, of a connection in the pool. Connections older than this value will be closed and replaced with new connections. This helps prevent database server issues caused by long-lived connections. Asterisk connection timeout, the amount of time, in milliseconds, that hikaricp will wait for a connection to become available from the pool. If a connection cannot be obtained within this time, an exception will be thrown. C3P0 configuration, alternative. 1. Add the dependency asterisk. 2. Configure C3P0 in hibernate.cfg.xml asterisk. Asterisk hibernate.c3p0.min_size, the minimum number of connections that C3P0 will maintain in the pool. Asterisk hibernate.c3p0.max_size, the maximum number of connections in the pool. Asterisk hibernate.c3p0.acquire_increment, the number of connections C3P0 will attempt to acquire at once when the pool is exhausted. Asterisk hibernate.c3p0.idle_test_period, the number of seconds that a connection can remain idle before being validated. Asterisk hibernate.c3p0.max_statements, the maximum number of prepared statements that C3P0 will cache per connection. Important considerations and best practices, addressing common Stack Overflow questions. 1. Database server configuration asterisk. Ensure that your database server is configured to allow a sufficient number of concurrent connections. Check the max_connections setting in your database server's configuration, example my.cnf for MySQL, postgresql.conf for PostgreSQL. Remember that the maximum pool size of your connection pool should be less than the max_connections of the database server. You also want to leave connections available for administrative tasks. 2. Connection leak detection asterisk. Use connection leak detection tools provided by your connection pool, example hikaricp's leak detection threshold, to identify and prevent connection leaks. A connection leak occurs when a connection is obtained from the pool but never released back to the pool, leading to eventual exhaustion. 3. Proper exception handling asterisk. Always handle exceptions carefully and ensure that connections are closed in finally blocks, even if an exception occurs during database interaction. Use try with resources for concise and reliable resource management when working directly with JDBC connections. Even when using Hibernate, close the session in a finally block to ensure that associated resources are released. 4. Transaction management asterisk. Use Hibernate's transaction management features, example at transactional annotation in Spring, to ensure that database operations are performed within transactions and that transactions are properly committed or rolled back. This helps prevent data inconsistencies and resource leaks. 5. Statement caching asterisk. Configure statement caching in your connection pool, example hibernate.c3p0.max_statements or hikaricp's cache prep stmts, to improve performance by reusing prepared statements. This can significantly reduce the overhead of database interactions. 6. Connection validation asterisk. Configure connection validation in your connection pool, example hibernate.c3p0.idle_test_period or hikaricp's connection test query, to ensure that connections are still valid before being returned to the application. This helps prevent errors caused by stale or broken connections. 7. Resource closing order asterisk. When closing multiple resources, example result set, prepared statement, connection, close them in the reverse order of their creation. This ensures that dependencies are properly handled. 8. Connection pooling in Spring Boot asterisk. Spring Boot automatically configures a connection pool, typically hikaricp, if you provide the necessary database connection properties in application.properties or application.yml. You usually don't need to explicitly configure a connection pool provider. 9. Monitoring and tuning * continuously monitor the performance of your connection pool and database server and tune the connection pool configuration based on your application's workload and performance requirements. Regularly review your application logs and database server logs for connection-related errors and warnings. Example: Stack Overflow questions and answers. Question Hibernate throws SQL exception, too many connections after a few hours. How can I fix this? Answer: This often indicates a connection leak or an insufficient maximum pool size. First, review your code for connection leaks. Use a connection leak detection tool. Then, increase the maximum pool size in your connection pool configuration, but ensure it doesn't exceed your database server's connection limits. Monitor database connection usage to determine the optimal maximum pool size. Question: My Hibernate application is very slow. I suspect a connection pool issue. Answer: Hibernate's default connection pool is likely the culprit. Migrate to a more robust connection pool like hikaricp. Configure minimum idle and maximum pool size appropriately. Use profiling tools to monitor database performance and identify slow queries. Ensure proper indexing on your database tables. Question: How do I configure hikaricp with Hibernate in Spring Boot? Answer: Spring Boot automatically uses hikaricp if it's on the class path and you provide the necessary database connection properties in application.properties or application.yml. You don't need to explicitly configure hibernate.connection.provider_class. Question: What's the difference between hibernate.connection.provider_class and spring.datasource.url in Spring Boot? Answer: Hibernate.connection.provider_class is a Hibernate-specific property that tells Hibernate which connection provider to use, example hikaricp. Spring.datasource.url is a Spring Boot property that configures the data source, which includes the JDBC URL, username, and password. When using Spring Boot, prefer configuring the data source using spring.datasource * properties, and Spring Boot will automatically configure the connection pool. You usually don't need to set hibernate.connection.provider_class explicitly. Conclusion: Hibernate's default connection pool is suitable for simple applications but quickly becomes a bottleneck in more demanding environments. Migrating to a dedicated connection pool like hikaricp, C3P0, or dbcp, and configuring it appropriately, is crucial for improving performance, preventing connection exhaustion, and ensuring the stability of your application. Proper connection management in your code, careful monitoring, and understanding your database server's configuration are equally important for a robust and scalable solution. By following these guidelines, you can effectively address connection pool-related problems and build high-performance Hibernate applications. Remember to always adapt the configurations and solutions presented here to match the specific requirements of your application and infrastructure. And if you do run into issues, the resources provided by the database itself, like its log files and monitoring tools, will often provide the best clues about what's going wrong.